Today we're going to talk about how to install end stops on the FiSec Spider version 1.1. Now there's two types of switch end stops that I want to talk about. First we have the one that has circuitry on it, so this one will have capacitors and resistors across it and then a switch to create a circuit. Now it has a signal wire, a ground wire, and then it has a voltage wire. The one over here is just a simple switch that creates a circuit when depressed. So it's got a red wire, in this case it's not voltage, it's signal, and then it has a ground. So I'll be talking in depth about these in a second, but this is your X end stop, your Y end stop, and your Z end stop. And inside these, I've marked green on the outside of this one for the signal pin, then black in the center, which is going to be our ground, and then we have red, which is voltage. Now it does change, and I'll show you this on the actual diagram. So if we go over to our desktop for a second, you can see that the FiSec Spider is right here. If you click on it, you can then look up anything about the board that they have documented. But I'm going to show you what's inside there that's kind of important. They show switch end stops right here and the wiring for them. But up here is where your X minimum, your Y minimum, and your Z minimum reside. And as you can see, it's the signal pin, which has got a pin number PB13 for your X minimum, then ground right here, and that traces out to your end stop. So that's how you're supposed to connect it. So it's signal and ground. But the other one's going to have voltage. And just so you know, they reversed it on the other ones down below. So it's technically written on the silk screen of the board as your X maximum, your Y maximum, and your Z maximum. But these can be used for other devices such as runout sensors and power detect or whatever you like, depending upon your knowledge set. So what we're going to do is go back over to the board and hook this up and get it ready to actually work with it. So back on the workbench, I'm going to take the connector that I have right here, and I'm going to align the pins according to their configuration. So you can see that voltage is on the right, ground is in the center, and then the green wire being signal is on the left. This one, on the other hand, is going to be different. So we're going to hook this up to ground and signal. So I'm going to orient it so you can see it. So the pin for voltage is empty. So I'll push that down. Now I'm going to prepare the board just so we can use 5 volts in just a second, but I'm going to pop out the actual SD card. In this case, I'm using an 8 gigabit SD card. So I'm going to slide that in, and I'm going to place this in the computer, and you may hear a beep. And then the other thing I'm going to do is change the power. So if I currently plug this in the default state that the board's in, there's no power. But if I unplug this and then move this pin over here to the top 2, you'll be able to see that the board will now be on USB power. So let me align that, let you see it, and push it down. So now I'm going to plug it in and we'll have 5 volts of power. So when you're actually running the board in the future on PSU power, what you're going to have to do is move the actual jumper cap back down. But for now we're going to leave it that way so we can actually program it and test it without PSU or power supply for power. So let's go back over to the desktop on the computer. We're going to go over to VS Code. I've already downloaded and extracted the most current version of Marlin. So I'm going to open a folder. I'm going to go to my downloads folder, open up the Marlin folder, then the next Marlin folder, then select folder. Inside here, the first thing that we need to do is set our default environment in a few moments so that our chipset is correct. And the current one that we have here is the Mega 2560, which is the default for ramps, which we're not using. So we're going to go over to our Marlin folder, our source folder, our core folder, and boards.h. And then we're going to search on Spider. And that'll bring us to our chipset definition for our board. This relates to a pins file, so we're just going to copy that. Then we're going to minimize this in a second, but I want to show you that the actual chipset over here is STM32F446. That's what we're interested in a little bit later. So I'm going to minimize the core folder, the source folder, go to configuration.h. I'm going to search on motherboard. I'm going to place ours over the ramps, so I'm going to paste it right here. Then I have to change the serial port from 0 to -1. Then what we'll do is we'll search on our end stops, because I have to show you something. So if we do a Control F and we search on end stop, and then I believe if you hit enter twice, it'll bring you to the end stop settings. As you can see here, we have 3 enabled, being X minimum, Y minimum, and Z minimum. You can enable other ones, but at the moment it's not needed. But down here you see that there's a pull-up resistor. This smooths out the signal for voltage that the board sees. So it's trying to see a certain level of voltage, either 3.3 volts or 5 volts, depending upon your board. And the same thing is true for the pull down resistor. But in this case, one of our end stops has circuitry on it. So we're going to have to change the false to a true. And that is done because if we didn't change it, it would say that it's triggered. By reversing the logic from false to true, it'll say open. So now that we've resolved this issue, we're going to have to set up the actual build again. So I'm going to go over to my INI folder. I'm going to find our chipset, which is STM32F4.ini, and I'm going to search on FISEC. And then down here you can see that our board definition is going to be the FISEC S6 8000. So we're going to copy that. We're going to close out of the INI. We'll go over to platformio.ini. We'll highlight the chipset that's currently there and paste ours over it. Now that we have that set, we're going to hit the clean button down here for platform.io. And then the next thing we'll do is an actual build. So I'll click on the checkbox. So as this is building, you can see in .pio that you have a FISEC folder, and then it's going to start populating. If you see a failure during your first build, hit the checkbox a second time, because if something does fail, it may be that something's building out of order. If it does fail after the second time, then find the very first error that's in red in this list and correct it, and then compile again, being the checkbox. It's actually compile/build, but as you can see up here, it's compiling. So a bunch of compiles together would be a build. So now that we have that set, we can see our build right here, which is firmware.bin. So we're going to right click. We're going to go to reveal in Explorer. We're going to check on our boot drive. In this case, it says old.bin, which means that it originally was firmware.bin. And to prevent it from reloading again, they renamed it old.bin. So let's go back over here. Right click on firmware.bin and send it to the boot drive. So now we have it. So we'll go back over to the desktop and we'll actually load it. So I'm going to pop out the drive. I'm going to take out the SD card and I'm going to slide it in here. Then what we need to do is power it up with the USB power. You'll hear a beep if it works correctly with your computer. And then after it's loaded, you're going to press the reset button once and then it'll beep again. Then we'll go back over to, in this case, our desktop, and we'll bring up Pronterface so we can test it. So currently it's not going to be on COM port 1. It may be in this list, but I'll show you a way to confirm what it is for your computer. So if you click on Device Manager by typing it in, and then a little device manager will come up that I'll bring over to the screen so you can see. And inside here, if you go to ports for COM ports, you can confirm that it's COM port 6. So let's change that to a 6 in the dropdown. You can also change the number by highlighting this and then changing the number to what you have. We'll click connect. And as you can see, it says connecting printer is now online. So to test the end stop, which I'll show you now, is we'll go over to the actual field here and type M119, enter. And what you see is there's 2 open. Now the third one down here obviously does not have an end stop, so it says triggered automatically. So what we're going to do is we're going to trigger the switch end stop with our finger here. And I'm going to do M119 again. So now you can see it's triggered. So if I let go, it now says open. So if I do the same with this one, you may see a light. Now I'll do the command again. And you can see it's triggered. And if I let it go and then press enter, it's open. So at this point, I want to let people know that if you want to see a video early that I post on Patreon, it'll be up there for Patreon subscribers. I will place a thank you in the end of the video for my patrons and for the people that donate on PayPal, because I'm eternally grateful. And please remember to like and subscribe. And everyone take care and have a nice day.